Assalamualaikum warahmatullahi wabarakatuh. My name is Karunisa Faiza binti Muhammad Karim Faris. In this video, I will explain and demonstrate my mini project for ECE 431 computer programming. For this mini project, each students are given one mathematical problem involving trigonometric equation to be solved based on the task given. Students need to apply the ability to create, select, and apply the appropriate techniques, resources, and modern engineering and IT tools in solving the problems. Moreover, the objective of this mini project are to give students the experiences on how to design and develop a fully functional C++ program to perform a complete algorithm and method to be used in the project. So, this is my equation and the values that I use in this mini project. Throughout this video, I will explain code contents and also the demonstration of the program. Firstly, to display the menu, I have used a function that returned by a value. The function prototype have been declared as an integer menu, and then the function is called within the main function. Alongside displaying the menu in the menu function definition, a value that need to be inserted as OPT is returned to the main function. The value is then applied in the switch case in the main function as an option to start or exit the program. For the switch case, the value of OPT will be stored as integer display. When the display value is 1, the program will start to execute to another task. But when the display value is 0, the program will be displayed you have exited and the program will exit. Otherwise, when the integer display is neither 1 nor 0, the program will exit directly. Next, for repetition and array elements are used in task 1. The for repetition is used to looping the statement inside of the loop with 320 times. The arrays is applied in the statement inside of the loop, which to calculate the value of x and function with the increment integer of I of 0.5. All of the 320 values then is saved into the arrays of x and function that declare with the size of 320. After that, the function with no return value which has been declared as void range x is used to display the value of x and function within the range inserted by the user. The first value inserted by user is stored in variable range 1 and the next value is stored in variable range 2. The value of x and function will be displayed within the condition of the for statement where the formula of x and function will calculate starting with the same value of range 1 and end with the range 2 with the increment of 0.5. For task 2, the first filter which to get the average from the first 100 function value is obtained by using the for repetition loop with the condition of integer j is starting from 0 until 100. This process is done in the function returned by a value named as display average. As the for loop is looping for 100 times, the value of function is added and divided with 100 and saved into the variable average. The average is then added to each of the value in function array. The filter 2 is done within the function passed by reference named as display std_dev. In this function, the pointer argument is applied. The sum up is declared as a pointer in the function prototype display std_dev. This function takes a pointer argument and pass an address, which can be the value of a pointer variable. In the function definition, the value of pointer sum up is modified and the value is used to calculate the standard deviation. To get the standard deviation, the first and the last 50 of the new function is added and divided by 100 to get the value of mean. Then, variance also need to be calculated for both of the condition in the for loops. The standard deviation is then subtracted from each of the new value of the function. For the last filter, which to get the final value of the new function passed by reference with alias is used to pass the address of the argument. The highest value of the last 100 of function new is obtained by using the for loop starting with the 119 until 320. For the statement inside of the loop, if the new function for the last 100 value is larger than the variable max_val, which must be declared with a lower value, the highest value in the function new will be stored as max_val. Then, the highest value is added to each of the function new and denoted as ffinal. For the values obtained from the filters, such as the average, standard deviation, and the highest value, are returned to the main function to be displayed. Next, task 3 is done in the files function. The values from ffinal are stored in a file named as Kairun. In order to write data in the file, the offstream is used. The control flow such as the if-else statement is also applied in this task. If the file is open, all of the values of ffinal is stored and the file is closed. Else, when the file is unable to open, the program will display unable to open file. After that, in order to read the data from the file need to be reopened by using if stream. When the file is open, users are able to insert two values for range of x noted as variable a and b. In this condition, the while statement is used to make the counter variable increasing as to read the ffinal values line by line. Furthermore, in order to display the ffinal within the range inserted, the condition for the other while statement must be the value of a inserted is less than b. Then, the statement inside of the loop is operated following the condition. Lastly, for task 4, referring to the function quantiles, in order to get 5 quantiles, the difference between the maximum and the minimum value of ffinal need to be obtained and divided into 5. Then, the operation to get the average, standard deviation, lowest and highest value are done in the functions that have been called within this function quantiles. But before that, the structure elements named as quantinfo have been used in this part. All of the variables that can be used by all of the quantiles are declared as structure members, and some of the members are initialized with 0 to make sure the variables that need to be used in the next quantiles is start with 0. From the first quantile that done in function quantile 1, the info1 is declared as the variables with data type of structure quantinfo. After that, whenever to access the variables that declare as the structure members, the variables need to be called with the structure data type variable and the dot. For example, in the quantile 1, to access the average Q, the average Q need to be written as info1.averageQ. Furthermore, to display the number of contents each of the quantiles, the condition in the if statement representing the range of the values in the quantiles. While in the loop, the values of ffinal within the range is stored in the array of quan1. Moreover, when the index of quan1 contains a value, the variable cal will increasing by the increment of 1. The loop will still looping until the condition is met. The process to get average, standard deviation, lowest and highest value are same in the process in task 2. All of the progress in quantile 1 are repeated in the quantile 2 until 5. After the program is executed, this menu will be displayed. Then users are given an option to start or exit the program. After I press 1, the program is started and user have to insert a range of x to display the fx. For example, I am inserting the range of 1 until 5. After the fx and x are displayed, this program will automatically display the average, standard deviation and the highest value of fx that have been obtained through the filters in task 2. Next, for task 3, The value of F final is automatically stored in the Khairun file. And this program will ask user to insert range of X After I insert a range, the value of F final are displayed within the range and then directly display the analysis data from task 4. From the statistics, it shows that the values of F final are mostly in the quantile form, with 307 numbers of values starting from 25.0967 until 84.3259. The average and the standard deviation for this quantile are 48.0141 and 6.50297 respectively. In conclusion, from this mini project, students are able to apply the elements of C++ that have been learned in ECE 431 computer programming in order to solve the mathematical problem given. By applying the elements of C++ program such as functions, arrays, pointers, and many more, it is more practical and simpler to create the solution for this mini project. I think that's all from me. Thank you for watching, and I hope you understand and enjoy this video.